Welcome students. As you know that the nth order linear differential equation with constant coefficient, the general form is f of d y equal to x, and the solution of this equation solution means general solution of this equation consists of two functions. One is called complementary function and one is called particular integral. uh, in our last lecture you have seen how you can find the complementary function like this type of problem in which the right hand side was 0 and you need to simply find these solutions, right? There are some formulas by which you get the solution, and you notice that if the equation is third degree then it consists three constants. If the equation is second degree or second order, it consists two constants. If it is third order, it is consists three arbitrary constants, right? So an nth order differential equation consists of n arbitrary constants, and all the arbitrary constants are have to written in the complementary function form, right? Now in this lecture we will learn how to find the particular integral of the differential equation f of dy equal to x. Okay, so the particular function means we need to calculate y. So y is basically what? 1 by f of d into x. Okay, 1 by f of d into x. So here is the definition. So the expression f of d into x is defined to be that function of x. That means 1 by f of dx is equal to suppose y, and y is any function of x which when operated upon by f of d gives x. That means if f of d acting over this y, okay, we get x. So for example, like 1 by d square plus 3d. Okay, so this is your x. This means the right hand side part is 2 plus 6x, right? So you may get any function. Suppose the function is x square, the original function is x square. So if you operate d square plus 3d over x square, you get what? 2 plus 6x, right? So that means 1 by f of d according to this definition is the reverse of the operator f of d. Okay, so 1 by f of d means f of d is directly acting. That means f of d is differentiation over the function, and 1 by f of d means integration over the function. So 1 by d in operator on x means integration of x dx. Okay, integration of x dx, and dx means derivative of x. Okay, now how to find the general method of getting particular integral. Okay, so suppose if x is a function of x, if x is any function of x, and f of d is a linear operator like d minus alpha. Okay, f of d is a linear operator, suppose d minus alpha. So when 1 by d minus alpha acting over x, the formula is e to the power alpha x integration of x e to the power minus alpha x dx. Now you have to remember this formula. Okay, now I will explain you how we get this formula. Okay, so basically what, as from definition, 1 by d minus alpha x, we will get some function of x, right? So y. Okay, so that means when d minus alpha operate on y, you get x. That means d minus alpha when operate on y, you get x. So that means dy dx minus alpha y equal to x. So this is a what? Linear differential equation with integrating factor e to the power integration p dx. That means e to the power integration of minus alpha dx. Okay, that means alpha is constant here, alpha is any constant, so that means e to the power minus alpha x. Okay, hence its solution is given by, how we write the solution, y into if equal to integration right hand side, that means x into if dx. So that means y e to the power minus alpha x equal to integration of x e to the power minus alpha x dx. Okay, now if you let this e to the power minus alpha x to the right hand side, what we get? Y equal to e to the power alpha x integration of x e to the power minus alpha x dx. Okay, now I think that you have understood how why we can write 1 by d minus alpha operating over x equal to e to the power alpha x integration of x e to the power minus alpha x dx. Okay, so you have to remember this. So now if we replace alpha by minus alpha, then we get 1 by d plus alpha operating over x equal to alpha, in place of alpha write minus alpha. So e to the power minus alpha x integration of x e to the power alpha x dx. Okay, now as you know that the particular integral, you shall never add any constant, okay, of integration after integration is performed in connection with the method of finding particular integral. So you have to remember that in particular integral we are not written any kind of constant, because all the constants are adjusted with the complementary functions. Okay, so this method, the above method, is the general form of finding the some special form of function x. Okay, so like this method we will use when we need to find x of the form sec ax, cosec ax, sec square ax, cosec square ax, tan ax, cot ax, like. Okay, or any other form not covered by shortened method. Okay, so there are some shortened method, we'll discuss this later on. But when this x is of the form sec ax, that means right hand side there is form of the form sec ax, cosec ax, sec square ax, cosec square ax, tan ax, cot ax, then we will apply this method. Okay, so here is a corollary is that suppose x is our e to the power ax, suppose x is our e to the power alpha x, suppose. Okay, and f of d is d minus alpha whole to the power n, d minus alpha whole to the power n. So what is the formula? X to the power n by n factorial e to the power alpha x. Okay, that means the particular integral is 1 by, so particular integral of 1 by d minus alpha whole to the power n e to the power alpha x equal to x to the power n. Okay, remember it, x to the power n by n factorial e to the power alpha x. Okay, now how we get this? So 1 by d minus alpha whole to the power n operating over e to the power alpha x means, so you just separate it. So d minus alpha 1 and n minus 1 different. Okay, so we know that what is the formula for that? E to the power alpha x integration over x, here x is itself e to the power alpha x. Okay, x is itself e to the power alpha x, and there is e to the power minus alpha x dx. Okay, so by the law of index, it is e to the power alpha x minus alpha x, that means e to the power 0, so that means 1. So integration of dx, so integration of dx means x. So what we get? X e to the power alpha x. Okay, and here is 1 by d minus alpha whole to the n minus 1. Now again separate d minus alpha, and here is n minus 2. Okay, now that means how we solve it? E to the power alpha x. Okay, and here is x is what? X e to the power alpha x, and this is e to the power minus alpha x dx by the formula. Okay, so again here it will get e to the power plus alpha x minus alpha, that means e to the power 0 1. So integration of x dx, that means after integrating you get x square by 2 factorial. Okay, now similarly do this pattern, we get what? X to the power n by n factorial e to the power alpha x, x to the power n by n factorial e to the power alpha x. Okay, so what you have to remember is that there is two methods. One method is that we know that f of d can be factorized into linear factors. Okay, so suppose it is n degree polynomial, so we can factorize it into n factors. Suppose the factors are d minus alpha 1, d minus alpha 2, d minus alpha 3 up to d minus alpha n. Okay, and operating on x. Okay, so that means for the first one, 1 by d minus alpha n x, you get what? E to the power alpha n x integration over x e to the power minus alpha n x dx. Okay, so similarly you do the procedure. Okay, or in other words, you may directly decompose into its partial fractions. Okay, as you see from the examples. So you can write like a1 by d minus alpha 1 plus a2 by d minus alpha 2, like this way. Okay, operating on x. So basically you just do this in one way. That means this method one was first you operate for the last one, then do the before last, then do the again the before last, like this way. And here you can directly use it using partial fraction. You can directly use it because there is an integration, there is multiplication sign in between, and there is addition sign in between, so addition can be split, right? So a1 e to the power alpha 1x integration of x e to the power minus alpha 1x dx plus this way. Okay, so basically method 2 is very convenient. Okay, of these two methods the latter one is convenient method, right? So here is an example, solve example. So suppose we need to solve it, d square plus a square of y equal to cot ax. Now you need to first find out the complementary function. So how you find out? The right hand, put the right hand side 0. So auxiliary equation is what? D square plus a square equal to 0. That means d equal to plus minus I. So this is a complex roots. Okay, real part is 0. So that means according to the formula, cf is e to the power 0x c1 cos ax plus c2 sin ax, right? That means c1 cos ax plus c2 sin ax, c1 ct being arbitrary constants, right? Now particular integral means this is that na 1 by d square plus a square is factorized into d plus ai and d minus ai operating on cot ax. That means now you do the partial fraction. So you can write it 1 by d minus ia plus 1 by d plus ia. Okay, so and 1 by twice ia come out and operating over cot ax, right? Now 1 by d minus ia cot ax means what? E to the power I into ia into x, right? Integration of e to the power minus iax cot ax dx. Now e to the power minus ix, e to the power minus ix means cos x minus I sin x, right? This is called de Moivre's theorem or Euler's theorem. E to the power ix equal to cos x minus I sin x, right? E to the power ix is cos x minus I sin x. So this is means e to the power minus ix means cos ax minus I sin ax, right? And cot ax means cos ax by sin ax operating over dx. Okay, now this is means what? E to the power ix integration multiply cos square ax by sin ax minus I, here will be cos ax operating on dx, right? And cos square ax means 1 minus sin square ax by sin ax. So this is like cosec ax minus sin ax minus I cos ax operating on dx. Okay, so integration of cosec x means 1 by a log 10 ax by 2 means ax by 2 plus 1 by a cos ax minus I by a sin ax. Okay, so similarly you do for 1 by d plus I cot ax. Okay, and adding up. Okay, that means adding up you get this formula. Okay, so you know that e to the power ix means cos ax minus I sin, and this is again minus of this. So do the thumb hand calculation and you get this function. Okay, so required general solution is complementary function plus particular integral. That is complementary function is this c1 cos ax plus c2 sin ax, and particular integral is 1 by a square sin ax log 10 ax by 2. Okay, where c and c1 and c2 are arbitrary constants. Okay, here is a similar problem. Again you can solve it by hand calculation. Here just you remember that 1 by, here function is 10ax, right? And 1 by d minus alpha, so e to the power I alpha integration e to the power minus I alpha into function dx. Then you just need to use Euler formula, then multiplication. Okay, and just rationalize it. After rationalize uses a formula. Okay, and integration formulas, and do some calculations. And for d plus ia you just replace plus I, you just replace I by minus I, you get d plus ia. Okay, so by this way you can find the particular integral. Okay, so our required solution is y equal to cf plus pi. So cf is as it is and pi what you get, right? Okay, so here is some uh, your homework is all the examples and exercise 5b. Okay, if you have any doubt then let me know. Thank you all.